Glad that interests both of us. Welcome back to the drive-thru, ladies and gentlemen. Give me some, Shiva. Yeah. All right. Brought to you by the Deli. Hungry? Stop by the Deli. Get a double stuffed Oreos. There's been 8 double stuffed Oreos stolen from the deli in the last 29 hours. Serious crime. I know. I did find that out. It's less than double stuffed. Unacceptable. Now, the question would be, is that double refer to the height or the volume? I guess it'd have to double the height to double the volume. Mass? I still think you'd have to double the height to double the mass. Right, the mass of the cream. Okay, here we go. So, well, that minute was a waste. Let's get started on the lesson. We are finding maximum and minimums of functions with 2 variables. So we're capping it at 2 for today. Okay, so this will all be z equals f of x comma y. You already did this in chapter 3, but you did it for 1 variable. Okay, so look, this process should look familiar. Find the critical points, okay? Find the discriminant. You don't know what that is, and that's not that good of a word, but that's what we're going to call it because that's how I heard it referred. And then use the second partials test to determine if these critical points are relative maxes, relative mins, or saddle points. Right? Now we are in the spot where a point could be a relative minimum and a relative maximum at the same time. Is it 12.8? 12.8. Thank you, Mish. I'm like Big Mish. Alright, so how do we find a critical point? There's 2 different ways. Each partial could equal 0. Okay, so there's an and here. Or either partial could be undefined. Okay? Got it? If you think back to our little experiment, that should make us feel better because the gradient was undefined at every spot along this semi-ellipse that I'm holding, and every spot along the semi-ellipse was a what? Was a relative min. So it's all good. Okay. It really doesn't take long from here, so if I go too fast, we'll come back to it. But I want to make this video less than 10 minutes. Okay, so instead of doing a second derivative test, which is what we used to do, we will now do something that's called a second partials test. Okay. In order to do the second partials test, we just need to find this thing called the discriminant. The discriminant is going to be called D or triangle. You'll see it referred to in both ways. Okay. Oh, I forgot. We have to do an example. There's no way this will be less than 10 minutes. Okay. And it's a fat delta. Okay. All right. So it's f sub xx times f sub y. I don't want you to think that's a dot product, so I'll use parentheses. And then minus f sub xy squared. Okay? Got it? Nope. All right. So the second partials test says this. Okay, first of all, it only works when the partials are both equal to 0. So we can't use the second partials tests when they're undefined. So that's we'll only be using these when we can set things equal to 0 and solve for them. Okay, step 1. If D, that's not step 1, this is rule number 1. There's 4 rules to the second partials test. All you got to do is pick the right rule for the right situation. If D is positive and f sub xx is also positive, I don't need an is there, then let's see, positive, that's going to be a smile, so it's going to be a relative min. And I'll explain to you what I mean by smile in just a second, okay?
When you were standing over there.
Okay, let me explain something here. Do you see this or f sub yy? I hope that confuses you. Good. Here's why. Think about what D equals. Let me change color. D equals f sub xx times f sub yy minus f sub xy squared. Now, can this term ever be negative? It cannot be. So how is the D going to be negative? Well, this has to be negative, okay? Right? Well, if the D is positive, then that means this has to be more positive than this. The only way this thing can be positive is if what? Both of these have the same sign. So that's why you don't have to check to see if fxx and if fyy is positive. You just have to check either one of them. Okay? Okay. Rule number 2. Oh, come on. Get it together. All right. If D is positive and the second partial is negative, negative makes me frown, frown, then then relative max. Okay? So far so good? 3. If D is negative, then we have a saddle point. A saddle point is a point on a saddle. It's a point that could be considered a relative min and a relative max at the same time. Okay? And that's not a very good saddle, but that's the best you're going to get out of me. See your book. Okay? And then we have our 4th rule, and that is if D is 0, or discriminant, then the test fails. Okay? Got it? Now, there's a little group of pictures that you can help, or that you can use to help you remember them. And the book calls them pigs. The 4 pigs. Now there's 4. All right, so the eyes are the partials. Okay? The nose is the D. If the eyes are happy and the nose is happy, then this thing's happy, and that makes it a relative min. So this is mini. Okay? This is all I'm doing is rewriting the 4 rules. Okay? So, if the second partial is negative, but the discriminant is positive, that person's sad. And by person, I mean pig. That is Maxwell. Okay? If the determinant is negative, we don't care what the partials are. This thing is a saddle point. Okay? That's a confused pig. Okay? And then that's the insane clown pig. And he doesn't tell us anything that's useful. Okay? So that's another way you can think about this so you can remember it. Got it? Alright. So, now let's just do one example. Let's say that f of x comma y is 2x cubed plus y cubed minus 3x squared minus 12x minus 3y. Okay? So I'm going to try to help you with this process. First thing you do is you just find f's of x. So, what's f of x? Quick.
6x squared minus 6x minus 12.
Okay. F of y? Okay. Either f sub xy or f sub yx. Why do I say either? Very good. Very good. They're the same thing. Maybe you remember that. That was on a test at some point in our life. Okay. So what is that? 0. Okay. 0. And then what about f sub xx? And f sub yy, just in case we need it, we will. It's 6y, okay? So you start out like that. And then you say, well, when does 6x squared minus 6x minus 12 equal 0? Well, that's 6 times x squared minus 1x minus 2. 6 times x minus 2 times x plus 1, right? I'll come over to this one. When does 3 times y squared minus 1 equal 0? That's 3 times y plus 1 times y minus 1. So y equals 1 or negative 1. Here, x equals 2 or negative 1. So look, we have 4 critical points. Do you understand that? The point 2, comma 1 works. The point 2, comma negative 1 works. The point negative 1, positive 1, comma, did I get that right? That's what I thought. Oh dear. Oh dear. I'm looking at the wrong thing. Okay, good. Negative 1, comma 1, negative 1, comma negative 1. Okay. Those are our 4 critical points. So the next thing you do, is you make a chart. And in this chart, you need 4 columns. Okay? The first column, you have your point. The second column, you've got your f sub xx. This one you have your f sub xy, and that one you have your discriminant. Okay? So, the point is going to be x comma y. F sub xx is going to be 12x minus 6. F sub y is 6y, and the discriminant, no, the discriminant is not 0. Oh, yeah. Hold on, this should be yy. This should be yy, sorry. Because we're going to need that, right? We're definitely going to need that. Remember what we're testing? Do you remember the discriminant? It's this times this minus f sub xy squared. Okay, so this, what's that? I don't. That's what this is. This is f sub xx times f sub yy minus f sub xy squared. Well, f sub xy is 0 in this one, right? Okay? So, now we just test our points. 2, comma 1, 2, comma negative 1, negative 1, comma 1, and negative 1, comma negative 1. All right, so this is 24 minus 6, that's 18. This is 24 plus 6, right? Is it 18 again? Oh, there's no y. Jeez. 18? I don't think so. Negative 18. Negative 18. Okay. And 6 times y. This one is 6. Negative 6. 6. Negative 6. Uh-oh. We did something wrong. No, we didn't. We're all right. We're all right. Okay? All right, now, evaluate this. Well, f sub xy is 0. So basically, we do f sub xx minus f sub yy. All we really need to do is look. This times, sorry. 18 times 6 is at 108, I think. This one's negative 108. Negative 108. And 108. Okay, good. So immediately, we know that we have no confused pigs, because we never had the d equal to 0. No, sorry. We have no insane pigs. We do have 2 confused pigs. When the discriminant is what? When the discriminant is negative, then we have saddle points. So, we have saddle point at the 2 in the middle. 2 comma negative 1 and negative 1 comma 1. And then here we have the d is positive, the partial is positive, happy gives us a minimum, okay? So relative minimums at 2 comma 1 and negative 1 comma 1. And that is that. Are you down? We do not have a relative max anywhere. Okay? I'll show you the graph and you'll feel better about it. Boom! All right. Hey, an addendum. Yeah, addendum. We did this wrong. This is wrong. Wrong. Because that is negative, okay? So, since we have our partial is negative, but our discriminant is positive, that is going to be a relative max at the point -1, -1. Boom!